Once you have a complete problem graph, you can switch to step 4, the orientation step of the project. This step will allow defining what hypotheses the project can move toward for its future, taking into account, of course, the state-of-the-art that you have previously established through the problem graph. In this step, we use a TRIZ tool, namely the Laws of Evolution tool. This tool will be the main tool used in the project framework to search for future directions of the technical object. So here, you can start by indicating the object you are working on. If, for example, your object has as its main function to train medical students, you will identify this main goal, which constitutes the basic function of your technical object. You can then go further by defining the 4 parts of the object and observing the different hypotheses according to the laws of evolution. You cannot do them all here, but we can at least address 1 or 2 to illustrate. When you write the hypotheses related to the laws, you have 2 possibilities. Either you write them manually, because you master the laws of evolution well enough to formulate your hypotheses yourself, or you let yourself be helped by the hypothesis formulator. The latter proposes a set of yes-no questions, which helps you better target what you want to note regarding your object. Here, for example, your educational arm. So obviously, everything is in English in the software, while you have written in French. There's therefore a mix of French and English in the proposed feedback. You can then analyze what is proposed. Example: does the arm for blood sampling train medical students satisfactorily? Does the arm use a form of energy for this function? Yes. Does the arm have a component that receives and transforms this energy? Yes. Does it have a component that is in direct contact with the students? Yes. Does it have a component that controls the energy? Etc. Through this set of yes-no questions, you then obtain a formulation of 2 hypotheses in a semi-automatic and pre-filled way. Of course, if you want to be more precise, you will have to go over these hypotheses again, that is, edit them and rephrase them to have hypotheses properly written based on the generated elements. For example, the software may propose formulations like, the project could focus on a redesign in order to optimize the way in which the main function is transformed. Or, the project could focus on the redesign in order to optimize the way in which the function is transferred to. But since you have not yet filled out all parts of the form, some elements are missing in the sentences. To do this part correctly, it is necessary to take the time to complete all the required information. Then investigate the algorithm law by law. Based on the suggested sentences, you can then edit and reformulate the hypotheses so that they express a plausible hypothesis for the future of the technical system. If a hypothesis seems useless, superfluous, or incomplete, you absolutely have the possibility to delete it from the project, to keep only the hypotheses relevant for the future of your technical object. By repeating this approach for each law of evolution, you arrive at a set of hypotheses accumulated here that will allow you to draw the potential futures of your technical object. This work gives you an additional argument to justify the future choices that you will make regarding the solutions to implement. That's why this step, although optional in Finder, is strongly recommended. It can really help the team go beyond classic or routine solutions and constitutes a real breakthrough lever to move the project toward a more innovative approach. Skipping step 4 means taking the risk that the project lacks innovation. Once step 4 is completed, you can move on to the next one, step 5.